My name is Stephanie Saylor, and this is a visual phasing workshop. We will be reviewing how to mark recombination points in example B in the tried examples. You should have tried it on your own after the last video. If you have not, please find the tried examples in the description box below and pause the video while you attempt example B, so you can get the most out of the review session. M and N have fully identical segments, green over blue. That changes to a half-identical segment, yellow over blue. Below that, we find that N and B do not share DNA for most of that chromosome. When we look below at the B and M comparison, we see a change from no match, that gray on the bottom, to a half match, yellow on the top, blue on the bottom. And we have found our 2 points of change indicating the recombination point. At the beginning of the comparison between N and B, there tends to be some concern about this little bit of yellow. Many ask me if this is a half match because it is yellow and moves to mostly red on the top, but it is not. If this was a significant segment or long enough stretch of half-identical matching for us to worry about, we would see that blue bar at the bottom of these browser results right here. Therefore, this is not a significantly long stretch of yellow for us to consider half-identical. It is still what we would call a no match, and we have no hindrance from making our line of recombination here. Moving to the right as we did before, we run into the next change in the M and N comparison. We move from siblings M and N sharing DNA on one chromosome, marked by yellow on the top, blue on the bottom, to a fully identical match, where they share DNA on both copies of the X chromosome they inherited from both their parents, as seen by green on the top, blue on the bottom. Looking to the one-to-one comparison below, in the N and B comparison, we see another change. N and B go from sharing no DNA with each other to sharing DNA passed down from a single parent, shown by the yellow top and the blue bottom of a half match. When we look below, we see the yellow top and blue bottom all through the area of a half match. So there is nothing holding us back from marking our recombination line. From the recombination line to the end of the X chromosome, there is the solid green and blue of a full match, also known as fully identical segments, so the DNA was inherited by both siblings on both copies of this chromosome. And we see no change, so it's not very exciting. But looking down on the N and B comparison, there is a change. The transition from a yellow-blue half-identical match to the gray-brown no match. Looking to the BM comparison, there's another change from the yellow-blue of a half match to not matching at all. As we already verified that there is no third change in the M and N comparison, we can draw a line of recombination happily. Looking at the end of the chromosome, there are no more changes. M and N stays the green-blue of a full match. N and B stays the gray of a no match, and B and M is also a gray-brown no match. All recombination lines have been marked on example B. Because the X chromosome is a sex chromosome, a word of warning for a change you may not be expecting when working with multiple male siblings. Remember, they only have one X chromosome that can match, so their chromosome browser results will look a little wonky if you're not expecting it. Go ahead and pause the video and teach someone about labeling recombination points using example C. Do not get overwhelmed with the number of recombination points you find in example C. It is treated just the same. We will review example C for extra practice and so you can check yourself in the next video.